In the second question here, there was 3 parts to it. 10 marks for the first bit, 10 marks for the second bit, and 5 marks for the third bit. In the first bit, we've been given a diagram of a cubic f of x. And we've been told that the roots of the cubic are x equals -3, x equals -1, and x equals 2. It's also clear to see from the actual diagram that these are the 3 roots. The points are across the x-axis. And we're asked to verify that this cubic can be written as x cubed plus 2x squared minus 5x minus 6. We're told that the point 0 minus 6 is also on the curve, so we can use that at the end in order to verify it, to double check. First of all, you should have realized that you've been given 3 roots. If you're given 3 roots and you need to come up with the original function, you need to turn these roots into factors. If x equals -3 is a root, I add 3 to both sides, and I can say that one of the factors is x plus 3 equals 0. If x equals -1 is one of the roots, I add 1 to both sides, and I say x plus 1 equals 0 is one of the factors. And I can do the same thing here. I subtract 2 from both sides, and I get x minus 2 is one of the factors. Now that I have the 3 factors, I just need to multiply them by each other. When I multiply them by each other, I'll hopefully end up with f of x that was given in the question. So if we multiply this out, obviously you can't multiply all 3 brackets at the same time. What I can do is I can take 2 of the brackets, multiply them by each other, and then multiply the 3rd factor by it afterwards. So what I decided to do was to multiply x plus 1 by x minus 2. When I did that, I ended up with x squared minus x minus 2. That's multiplying 2 of the factors by each other. We now need to multiply x plus 3 by that quadratic. And if I multiply that out, I end up with x cubed plus 2x squared minus 5x minus 6 equals 0. So I can say that if the 3 roots of the cubic are this, it could be written like that. However, that is not sufficient because there's an infinite amount of cubics that have these 3 roots. There's an infinite amount of different cubics I could get. I could get one that was twice as steep. The numbers would be different, but the roots would be the same. So in order to verify, to double check that this is actually the one we have, we need to sub in the other point. We can now say that we think the function f of x is equal to this. Is equal to x cubed plus 2x squared minus 5x minus 6. But in order to verify it, to double check it, I need to sub in the y-intercept 0 minus 6, and if I end up with the same on the left and the right, then I can say with 100% certainty that that f of x can be written like that. So I'm investigating if the point 0 minus 6 lies on this curve. Remember, the first coordinate is your x, the second coordinate is your y. And I could view f of x, the function, I could view that as y equals whatever. So instead of the f of x or instead of the y, I'm going to sub in a minus 6. And everywhere there's an x on the right, I'm going to sub in a 0. Obviously, if you're multiplying anything by 0, it just ends up as a 0. So everything cancels other than the last term. And I end up with minus 6 equals minus 6, which clearly it is. So therefore, I can conclude that f of x can be written as x cubed plus 2x squared minus 5x minus 6. And that's my final answer. I verified it and double checked it by subbing in this point. We can move on now and look at part 2. Okay, in part B here, there was 10 marks going. We've already dealt with the cubic function f of x, and we're now introduced to the linear equation g of x equals minus 2x minus 6. We're asked to identify the coordinates of the points where the line and the curve intersect, and in order to do that, they've told us to let f of x equal to g of x. If we let f of x equal to g of x, we'll be able to identify the points of intersection of the line and the curve. So I know f of x and I know g of x, so mathematically I just need to sub in. F of x, the left hand side of this equation, is x cubed plus 2x squared minus 5x minus 6. G of x, the right hand side of this equation, is minus 2x minus 6. So by doing this, this allows me to identify when is the curve equal to the line. The curve is equal to the line when they intersect. Now, obviously, if you have an x cubed, an x squared, an x, and a number, we're expecting this to be a cubic, so we want to move everything to the left-hand side. In order to do that, first of all, we're going to add 2x to both sides. So the x cubed stays the same and the 2x squared stays the same. I have a minus 5x here, and I'm going to add 2x to both sides. I also want to bring over, so that means the 2x on the right-hand side is gone. But I also want to bring over this 6, which means I'm going to add 6 to both sides. If I add 6 to both sides, I notice now that I've got minus 6 plus 6, they're going to cancel. So this makes life a little bit easier. I have an x cubed, I have an x squared, and then I can group these terms. I have minus 5x plus 2x, which is minus 3x, and minus 6 plus 6 is just 0, so it's gone. Now, you should realize that this is equal to 0. Now I need to factorize and solve this. This is an x cubed, which clearly means there's going to be 3 answers. But we've never really dealt with factorizing something like this. You should notice here that there's a common term. What I can do is I can just factorize out x. If I factorize out x, x into the first term is x squared. X into 2x squared is just 2x, and x into minus 3x is just minus 3. So first of all, I've got an x outside here, and I clearly have a quadratic equation I have a quadratic expression in my bracket. So if I factorize my quadratic, I have x squared plus 2x minus 3. So my factors are going to be x plus 3 and x minus 1 equals 0. And now that I've factorized it, I can just solve it, and I can find the x values, the x coordinates for the points of intersection. So obviously, in each case, I just let each factor equal to 0. My first factor is just x, so I just let x equal to 0. That's my first value. My second factor is x plus 3. So what I want to do is I let x plus 3 equal to 0. And I want to isolate my x, so I want to subtract 3 from both sides and say that x is equal to minus 3. There's my second value. To get my third value, I let the other factor equal to 0, add 1 to both sides, and get x equals 1. So I know that when x equals 0, when x equals minus 3, and when x equals 1, f of x is equal to g of x. Or in other words, they're the x values at the points of intersection. But obviously, to get the full marks here, I need to sub back into one of the original equations to find the corresponding y values. So for example, when x equals minus 3, I want to find the y value. But I know the points I'm dealing with here are on the curve, but they're also on the line. So I could sub into f of x or g of x. Now clearly, in order to find the y value, I'm not going to sub into f of x, because it's way more complicated than g of x. In order to find the y values, I'm going to sub into g of x, and I'll end up with the 3 coordinates for the points of intersection of f of x and g of x. So all I've done here is I'm trying to find the corresponding y values. If g of x is minus 2x minus 6, I want to work out what is the value of y when x equals 0. So I sub in, I just get g of 0. Everywhere there's an x, I sub in a 0, and I end up with minus 6. That tells me that when x is 0, y is minus 6. That's my first point of intersection between the curve and the line. To get another one, I sub in g of minus 3. So instead of an x, I just sub in a minus 3. I end up with plus 6 minus 6, which is 0. So I know that when x is minus 3, y equals 0. So my second point is minus 3, 0. The third set of coordinates we need here is when x equals 1. So I just get g of 1. Everywhere there's an x in the original function, you sub in a 1 and you end up with minus 8. So when x equals 1, I know that y equals minus 8. So these 3 points are the points of intersection of the line and the curve, and that gets you 10 marks in this case. Now in the last part of this question, we just need to plot these points and draw the line g of x. Okay, to get the final 5 marks, now obviously your diagram is going to be more accurate than mine, but you need to plot the point minus 3, 0, the point 0, minus 6, and the point 1, 8. You join up you'll notice that on that, the curve is on all 3 of those points. You then join up those 3 points using a ruler and you get your 5 marks. The 3 points of intersection between the line and the curve are minus 3, 0, 0, minus 6, and 1, 8. And that gets you 5 marks in that case. Okay, in question 3 here, there's 2 parts and there was 15 marks for the simultaneous equation and then 10 marks for the next part of the question. In order to get these simultaneous equations right, the key is to just organize yourself properly. If you've been given 3 equations, the very first thing you should do is just label the 3 of them. In this case, I'm going to label them as A, B, and C. It doesn't really matter what you call them. You could call them 1, 2, and 3, A, B, and C, or whatever. But at least now I know that this is equation A, this is equation B, and this is equation C. I need to continue here, I need to either get rid of all of the x's, all of the y's, or all of the z's. But clearly it's the easiest thing to do here by a long way is to get rid of the y's, because there's already no y in the third equation. So if I can just take the first two equations and get rid of the y's, that will allow, straight away then I'll have two equations and two unknowns, and I'll just be right back to junior cert simultaneous equations. So what I'm going to do is I'm going to take A and B and I'm going to try and eliminate my y's. So I realize that if I have a 3y in A and a 2y in B, clearly I need both of those numbers divided into 6. So I want to turn them both into 6's. If I multiply A by 2 and I multiply B by 3, I'll end up with 6y and 6y. But obviously plus 6y adds up to 12. I want plus 6y minus 6y. So I need to change the signs of one of them. It really doesn't matter which one you change the signs of. I'm going to change the signs of the second one, so that I end up with a plus 6y on the top and a minus 6y on the bottom, and they're going to cancel each other out. So let's just work through that now and eliminate our y's in equation A and equation B. So I've taken equation C and equation D, and I've noticed that the easiest letter to eliminate here is clearly x. If I have a 1x on the top and a minus 5x on the bottom, all I need to do is multiply equation C by 5. And when I do that, I have a plus 5x on the top and a minus 5x on the bottom. So they cancel out, and I end up with minus 15 minus 8, which is minus 23z. Minus 65 minus 50 is minus 115. So at this stage I divided both sides by minus 23, and I end up with z equals 5. Now that I've worked out that z is equal to 5, I can sub that back into equation C or equation D, and I can find the value of x. So equation C is x minus 3z equals minus 13. And I've already worked out that z equals 5. If I just sub in z equals 5, I work out that x must be equal to 2. Now that I know that z equals 5 and that x equals 2, I can sub both of these into either equation A or equation B, and I can find the value of y. So I decided to use equation A, which was 2x plus 3y minus z equals minus 4. I subbed in x equals 2 and I subbed in z equals 5. When I worked my way through it, it was relatively straightforward. I ended up with y is equal to minus 1. So the three circled answers here was your final answer, the values for x, y and z. So that was worth 15 marks to you, and now the next part of the question was worth 10 marks. Okay, the second part of this question, there was 10 marks going. We have an algebraic fraction and an inequality. You should have recognized this as the special case, where in order to eliminate my fraction, I'm going to multiply both sides by the denominator to be squared. I'm going to multiply both sides by the denominator to be squared, and in this case the denominator is x plus 2. So if I multiply the left hand side by x plus 2 squared, you should recognize that the x plus 2 on the bottom divides into one of the x plus 2's on the top, and I'm actually left on the left hand side with x plus 2 times 2x minus 3. On the right hand side I have 3 times x plus 2 to be squared, which I can just multiply out. So if I multiply this one out, I'm going to end up with a quadratic equation which I can solve. Once I solve it, I'll be able to draw a rough sketch of my curve, and I'll be able to find the range of values for which the fraction was greater than or equal to 3. Okay, so this one requires basic enough algebra. The left hand side, you multiply x plus 2 by 2x minus 3, and you eventually end up with 2x squared plus x minus 6. On the right hand side, you multiply 3 by x plus 2 to be squared, and you eventually end up with 3x squared plus 12x plus 12. And once you're on this line, you should recognize you have x squareds, x's and numbers, which means you have a quadratic. If you have a quadratic expression or a quadratic equation, you want to move everything to one side and you want to factorize. So when we brought everything to the right hand side, you end up with x squared plus 11x plus 18 is less than or equal to 0. And at this stage, you want to try and draw a sketch of your curve, which means we can now introduce an equals, just ignore the inequality for the next few lines, let it equal to 0, factorize and solve it. When I factorized it, I got x plus 9 times x plus 2. You then solve that, you get x equals minus 9 and x equals minus 2. So the roots of the quadratic x squared plus 11x plus 18 are minus 9 and minus 2. Remember that roots are the points where the curve crosses the x-axis. And there's a plus in front of the x squared, which means I know it's a u-shape. So because I know these roots, it allows me to draw a rough sketch of my curve. But that's not your answer. Obviously, I can't just ignore the inequality. I need to go back to the line, the last line where I had an inequality, to work out which region here is relevant. This line reads as 0 is greater than or equal to x squared plus 11x plus 18. Or in other words, it reads as the quadratic is less than or equal to 0. So I'm trying to identify when is this curve less than or equal to 0. It's less than 0 when it's below the x-axis. Or in other words, this region. The region between minus 9 and minus 2. If I take x values, any x value between minus 9 and minus 2, then I know that the quadratic is less than or equal to 0. So what I need to do now is I need to write that as an inequality. I can say that x, in this region, obviously it's to the right of minus 9. Or in other words, x is greater than or equal to minus 9. And if it's to the left of minus 2, I can say that it's less than minus 2. Now I cannot say that it is less than or equal to minus 2 because it actually says it in the question that x can't be equal to minus 2. But if you just look at the original question, the bottom of the fraction, or the denominator, was x plus 2. If my answer included that x was equal to minus 2, well, imagine if you subbed in a minus 2 into this denominator. You'd have minus 2 plus 2, which is 0. Or in other words, you'd have a 0 on the bottom of this fraction. And in maths, we're not allowed to have a 0 on the bottom of a fraction. So straight away, you should realize that x cannot be equal to minus 2 because of the denominator of this fraction. So in that case, you'd say x is greater than or equal to minus 9 and just less than minus 2. It's not less than or equal to minus 2. And that's your final answer, and it's worth 10 marks for this question. Okay, so if we multiply this one out, all I do is multiply out the left-hand side, square the right-hand side, and you end up with x squared minus 8x plus 12 is greater than or equal to 0. So what I want to do now, once you've got your quadratic, what you want to do at that stage is you let it equal to 0, you factorize and you solve it. When I factorize and solve it, I end up with x equals 6 and x equals 2. And I can use this to draw a sketch of the quadratic x squared minus 8x plus 12 equals 0. It's a plus in front of the x squared, so I know it's a U-shape, and I know the roots are 2 and 6. So I could roughly mark in that that's my 2 and that's my 6, and I draw myself a U-shape. But that's not my answer. At this point, I go back to the last line where I had an inequality. The last point I had an inequality was that x squared minus 8x plus 12 is greater than or equal to 0. Notice this time I want to know, when is the quadratic greater than 0? The quadratic is greater than or equal to 0 when it's above the x-axis. So this time above the x-axis, I'm referring to this part, this section, and this section of the quadratic. So make sure you understand why this one is different from the last part of question 3. This time it says, the last line with an inequality reads as, when is the quadratic greater than or equal to 0? I want to know when x squared and x in a number is greater than or equal to 0. You should recognize that what I've shaded in is two separate regions. If it's two separate regions, it must be two separate answers. The first region refers to all of the x values that are to the left of 2. If they're to the left of 2, then obviously they're less than or equal to 2. I'm putting in the equal to because there's been an equal to the whole way along. So it's x is less than or equal to 2 refers to 2 and then to the left of 2. The second region that I've marked in is to the right of 6. Clearly any figures to the right of 6 are greater than 6. So this time I would say that x is greater than or equal to 6. So when x is greater than or equal to 6, it refers to this region. When x is less than or equal to 2, it refers to this region. And there's no reason for us to eliminate one of our answers this time. That's your final answer for this part of the question, and it gets you 10 marks. In part B here, there was 15 marks going. You're given two equations and two unknowns. So clearly we have enough information here to find the value of x and the value of y. However, you should notice that there's an x squared and a y squared in the first equation, which means the only way to solve this simultaneous equation is by substitution. What I want to do is I want to take the equation that doesn't have a squared in it, and I want to isolate one of the variables, isolate either x or y. It'll be easier in this case to isolate the x because the coefficient in front of the x is smaller. So if I wanted to get x on its own from this equation, the first thing I would do is I would subtract 3y from both sides. And I would end up saying that 2x is equal to minus 1 minus 3y. If I wanted to continue and actually isolate my x, I would divide both sides by 2 and end up with x is equal to minus 1 minus 3y divided by 2. Now that I know x in terms of y, I can use substitution to rewrite the first line with only one variable in it. The first line, the first term was x squared. But in this case, instead of an x squared, instead of an x, I can put in this. So instead of x squared, it's going to be minus 1 minus 3y over 2, all to be squared. And the next term was plus x by y. But instead of plus x, I'm going to put in plus minus 1 minus 3y over 2, and it's going to be multiplied by y. Since that's a fraction, I'm going to write the y in terms of a fraction as well as y over 1. The last term is a 2y squared. For the moment, I've no bother with that, and the right hand side is 4. What you should notice here is that all I've done is rewrite the first line, except instead of an x, I've subbed in this fraction. And what I've ended up with is one equation and one unknown. The only unknown in this equation is y, which means I can use this equation to find the value of y. If I multiply this out, I'm going to end up with a quadratic. So from here, usually the problem students have is it's often with the first fraction. It's just squared, you're just squaring it. So at the moment I have minus 1 minus 3y on the top of the fraction. If I'm squaring it, that means I'm going to be multiplying it by itself. It'll become minus 1, the top of the fraction will become minus 1 minus 3y by minus 1 minus 3y. The bottom of the fraction will be 2 by 2, which is 4. The second term is relatively straightforward. If you're multiplying two fractions by each other, you just multiply the tops by each other and you multiply the bottoms by each other. Or in other words, clearly the denominators at the bottom here are simple. 2 by 1 is just 2. The numerator, or the top y, I'm just going to multiply y by this. Y by minus 1 is minus y. Y by minus 3y is minus 3y squared. So I don't really have any bother with that fraction. And then I got 2y squared equals 4. So all I need to do now is continue this on and then try and eliminate my fraction and turn it into a quadratic. Okay, so if you multiply minus 1 minus 3y by minus 1 minus 3y on the top of the first fraction, you end up with 1 plus 6y plus 9y squared. So I haven't really done anything with that line except that I multiplied out that bracket. Now you should recognize at this line that you need to eliminate your fractions. The first one is over 4, the second one is over 2, and the last two are just over 1. In order to eliminate your fractions in one go, you just need to multiply everything by 4. If you multiply the first fraction by 4, the 4 on the bottom divides into the 4 you're multiplying once, so you actually just rewrite the top of the fraction. It's 1 plus 6y plus 9y squared. The second fraction, 2 divides into 4 twice, which means it just becomes 2 times whatever's on the top of the fraction, which in this case is minus y minus 3y squared. All you had was 2y squared and you're multiplying it by 4, so it becomes 8y squared. Here on the right hand side you just had 4. If you multiply it by 4 you get 16. At this stage you should recognize if y squareds, y's and numbers. So I just need to manipulate it so that it becomes a quadratic. If you multiply 2 by minus y you get minus 2y. 2 by minus 3y squared you get minus 6y squared. If you group your like terms, and all I end up with is 11y squared plus 4y minus 15 equals 0. You should notice that 11 is a prime number, so it has to be 11y and y. And the difference between 11 and 15 is 4, so it's actually relatively straightforward to factorize this one. You end up with 11y plus 15 times y minus 1 equals 0. If I then let each factor equal to 0 and solve it, my first y value is minus 15 over 11. My second y value is y equals 1. Once you have your two values for y, we need to sub back into one of the original equations and find two values for x. You should remember from the start of the question that we isolated x and said that x is equal to minus 1 minus 3y over 2. Now clearly that's the simplest way for us to find x. In the scenario where y equals minus 15 over 11, I can just sub that in. Instead of y, I can sub in minus 15 over 11, and my x works out as 17 over 11. So I know that when y is minus 15 over 11, I can say that x is 17 over 11. That's my first scenario. The other option is that y could be equal to 1. So I just need to sub y equals 1 into this. If I sub y equals 1 into this, I end up with minus 1 minus 3 times 1 over 2, and x works out as minus 2. Which means that when y is 1, I know that x is equal to minus 2. And they're my two final answers for this. If you find those values, you get your full marks in this question.